of modeling with CNOSSOS EU and iNoise. This is the agenda for this session. First, I'll introduce you to iNoise, then I'll go into the CNOSSOS EU method, and I'll explain how the source catalogs are implemented in iNoise and how you can modify them to your own national vehicle types and railway types. I'll give you a very short demonstration of iNoise. I think most of you will know iNoise or Predictor anyway, so you'll be familiar with the interface. Then I'll go into the iNoise configurations and pricing. And because I think most of you will know both products, you might be interested in how do they compare iNoise and Predictor. So I'll do that also. And then I'll end with a question and answer session. So iNoise. iNoise is intuitive and quality assured noise cancellation software, environmental noise cancellation software for road traffic, rail traffic, industry, and wind turbines. It includes sound power databases. It supports the ISO 9613, the CNOSSOS method, and the iNoise method. It has free pro and company license configurations. And when you download iNoise, it automatically runs in free mode. So there's a free license already included in the setup. It's a subscription-based solution, so that reduces your initial investment. It's easy to use, intuitive. There's a getting started tutorial included. Easy to install. You do not need a hardware dongle. Like I said, it's quality assured. We have a full support of the ISO 17534 quality assurance standard. There's a QSI format support for exchange of model data, specifically for the ISO 9613 with other noise cancellation software. And it's a trusted software. It's used by thousands. So it's a very well-known software. So looking at the CNOSSOS EU method, that's of course the European calculation standard for common noise assessment methods, defined in 2015 by in the Commission directive. The first publication of the method was also in 2015. There were amendments on the method in 2020. And before I continue, you will receive this presentation as handouts, also including the hyperlinks to those methods. So that's easy for you after this session to look at. There's a consolidated version that was released in 2021. So that was based on the original method with the amendments. The method describes one propagation method for industry, road traffic, and rail traffic, including source models. There's a separate method for aircraft noise, takeoff and landing. Ground operations for aircraft noise, however, can be calculated with the industrial method. So what we have implemented in iNoise is the propagation method for industry, road traffic, and rail traffic, not the separate method for aircraft noise. This method calculates the long-term average LEQ level, the LAEQ for industry, road, and rail in octaves from 63 till 8000 Hz. The air absorption is according to the ISO 9613.1, and the first mandatory use of this method was for the European noise maps in 2022. And if you look at the road source model, it has 5 standard categories: light vehicles, medium heavy, heavy, 4A 2-wheelers, and 4B 2-wheelers. That's a separate type of 2-wheelers, I'll show you later, and an open category. There's one source height 5 centimeters above the ground for all these standard categories. It's a complex source model depending on the rolling noise. Let me just switch off the microphones. It's a complex source model depending on rolling noise, propulsion noise, studied tires, acceleration, deceleration, close to a crossing, for instance, and specific crossing types, road surfaces, slope gradient. So it's a quite complex source model. The CNOSSOS EU rail source model is a little bit more complex. That's depending on rolling noise, rail wheel roughness, impact noise, like crossing, switches, junctions, squeal noise, traction noise, aerodynamic noise, directivity, bridges. The source model is a 1/3 octave source model. However, for the propagation and the calculation, full octaves are used. So in fact, the source model is calculated in 1/3 octaves, but then it's shown in full octaves. It has two source heights at 0.5 meter above the track and 4 meters above the rail track. And the separate types of noise are also divided over these two source heights. Rolling noise at 0.5 meter, traction noise 0.5 meter and 4 meters, aerodynamic noise 0.5 meter, for impact noise, squeal and bridge noise all at 0.5 meter height. Then looking at the source catalogs in iNoise. There's one catalog called SourceDB that's developed by us and the Imagine EU Working Group in 2007, and that contains sound power levels for industrial sources. I have included the link to the original document that describes the background of the sound power levels in this database. It's a very convenient database. Then road vehicles and road services catalogs are included in iNoise. They are based on Appendix F from CNOSSOS, and this contains characteristics and types of vehicles, light vehicles, medium, heavy, etc., crossings, and also road services. Then there are railway vehicles at railway tracks catalogs in iNoise, and these are based on Appendix G from the CNOSSOS method. And that contains characteristics and types of rail vehicles and tracks. Between brackets, it says examples, and I will come back on that. The road and railway catalogs allow adding national road and rail vehicles, because every member state should define its own national road and rail vehicles. Looking at the railway catalog, the original RMR train types that were used in the interim method for the European noise mapping projects are included in the default rail catalog in iNoise. However, note that this default rail catalog is not part of CNOSSOS and therefore not officially adopted by the EU Commission. Every member state should have its own catalog. It should define its own catalog specifically for railways. For road traffic, most likely everybody can use the default catalog, but for the rail track catalog, every member state should define its own catalog. The emission of the RMR trains in iNoise are determined within an EU project done by Extrium, and that was based on a final report in 2014. So there is, of course, a background of the sound power levels of these RMR train types in iNoise, but like I said, in fact, there are no specific train types defined in the CNOSSOS standard itself. The CNOSSOS standard does define how to calculate the sound power level of trains using the coefficients in the tables G1 to G7. These coefficients are based on, for instance, wheel diameter, axle load, types of brakes. If you know that your type of train has that wheel diameter, that axle load, that type of train, yeah, then you can use the tables in the CNOSSOS method to calculate the sound power level. And then you can define your own train type. But the train types itself are not in the CNOSSOS standard. So that's why we have implemented a default train type catalog in iNoise with those RMR train types. So in fact, it means that every EU member state needs to classify and define their own national train types. Well, in Spain, that's done by ADIF, France by SNCF, and we will create catalogs also for iNoise based on the ADIF database and the SNCF database. We have not done that yet, but we estimate that start of next year, we will have these databases also available in iNoise. Looking at the road vehicle catalog, This is how you can view and edit the road vehicle catalog in iNoise. So here you see the standard vehicle categories, light vehicles, light trucks, heavy trucks, light mopeds, and motors and quads. And with the buttons add and delete, you can add new vehicle types or delete existing vehicle types. And here you see all the coefficients, all the information you need to add for a certain category. So if it has rolling noise, propulsion noise, studded tires, gradient, those are all optional for every road vehicle. The rolling parameters, the propulsion parameters, studded, etc. So there's a lot of information to enter. You can also use the text format of the catalog, and I've shown that in the next sheet. So this is again the road catalog, the light vehicles, etc. And this is, if you click on export, this is the text file that you get when you export this catalog. It's a very easy text format. You see code is one, light vehicles, description, light vehicles, reference, the reference text, if it's that rolling noise, propulsion, studded, gradient, all those options in the input form in iNoise are also available in the text format. And of course, you can also import the text format. So then you can create your catalog also outside iNoise and then import it in iNoise again. But like I said, you can also edit it directly in iNoise. So then the road services catalog. Here are the default road services defined in the CNOSSOS method, with per road service all the coefficients, per vehicle type 1, light vehicles, medium, heavy, etc. per octave. Then the railway vehicle catalog. So this is this example RMR categories that we have included in the default railway catalog in iNoise. So here you see, for instance, I've clicked on RMR category 1, block brake passenger train, and here are all the attributes of this vehicle, this train type. And the vehicle transfer, contact filter, traction noise, these are all taken from the tables in the CNOSSOS method, but not the named train type. That's not included in the CNOSSOS method. And after all these, behind all these step pages, vehicle transfer, contact filter, traction noise, wheel roughness, structure transfer, aerodynamic noise, you'll find all these tables that are in the CNOSSOS method. And there you can also add your own vehicle transfer or your own contact filter. So it's a quite extensive catalog. Then the railway tracks catalog. In the CNOSSOS method, there were two defined, a well-maintained and a normally maintained track. Then how do you enter it in iNoise? Well, this is an example on how to enter a road item. So you enter, for instance, slope, percentage, then you select the road surface from the road surface catalog. Then you select what type of category of your road traffic, for instance, category 1, then the hourly flow in the day period, the speed in the day period, the hourly flow in the evening period, the speed in the evening period, etc. And based on that information, if you then click on the emission tab page, iNoise calculates the sound power level, of course, according to the CNOSSOS method. And this is the average sound power level in the day period, evening period, and night period per meter. That's for a road item. Then for a rail item, you select, for instance, from the default catalog, a train type, RMR category 3. Then you select if it's a constant speed, an idling speed, an accelerating or a decelerating speed. Then the hourly traffic flow per period, how many of these trains in the day period, what is the speed of this train. Then you select what type of track transfer, what type of wheel roughness, the impact noise, bridge radiation, the curvature, and the number of switches per meter. And also based on this information, iNoise calculates the sound power level for the railway or the specific sources. I explained that there are several types of sources for railway traffic. The rolling noise at 50 centimeters, half a meter above the track. Traction, aerodynamic. Well, this train type is not a high-speed train type, so it does not have aerodynamic noise. I also did not select a bridge. It was empty, so there is no contribution from a bridge. And the traction noise at 4 meters height, and there's of course also no aerodynamic noise at 4 meters height. And this is then in the day period. So here you switch between day, evening, night, this selection list. So that's the railway item. Okay, before I go into a short demonstration of iNoise, I want to show you the EU noise mapping project flow that has been used for the noise mapping projects in 2022. This gives you a general idea what steps you need to do in order, in this case for the EU noise mapping projects, the purpose was to calculate the population exposure. But of course, you can also just calculate your noise maps. Of course, you start with GIS data, for instance, shape files of buildings, roads, ground cover, address points for the number of people, height lines. Of course, you import that in your main model in iNoise. There are all kind of import options. Then within iNoise, you create your receivers at facades. There are specific CNOSSOS methods how to do that, and we've implemented those methods in iNoise. Then, if it's a really huge model, you tile your main model. However, in many cases, it's not needed because iNoise can really handle quite large models. It has an open memory model. You can use all the memory you have to create your model. But if some cases your memory runs out, you can tile the model into smaller tiles, and in some cases it will also speed up your calculation. So tiling is in some cases also convenient. You calculate the tiles, then you import those tiles in your main model again. There's an automated procedure in iNoise to do this. Then you calculate your population exposure in iNoise, and then you export that to whatever software to make your report of your noise exposure, your population exposure. So next, what I want to do is to present you a small demonstration. I will show you a CNOSSOS model with the noise contours for roads, railways, industry, and I'll show you a little bit more about the road and railway catalogs. Then I will create a new CNOSSOS model and show you how to import buildings and roads from shapefiles. Then I will also import the agglomeration boundary as a diff area item. And that's convenient, this diff area item. I will show you later on. Then I will create the receivers around the buildings at the facades. And that's done by first showing the buildings thematically colored on the property, designated use, because you want to only select the buildings within your agglomeration, in this case the diff area, with the designated use being equal to residential. And then you can use the menu option Edit, Batch, Create Items, Receivers at Facades. So this just shows you a small amount of the features of iNoise. Okay, I will now switch over to iNoise. So this is my calculated model in iNoise, and this is the main group. And this model contains of 3 groups. It has an industry group, and here you see the noise contours only of the industrial group. There's one area source over here. Before I continue, I want to show you with the info option what this model contains. So this model contains one area source, one railway, 1961 roads. It has 25,000 contour points. It has one grid with 61,000 points. It has 124,000 receivers, 51,000 buildings. Show you. Then it has 47,000 address points and one diff area. And the diff area is that dotted polygon here. This black one. That's this diff area. So these are the noise contours for the industry. These are the noise contours for the railway. There's one railway, that's this one. And as you have seen during the calculation, a fetching radius has been used to calculate the railways up until a certain distance. Then here are the noise contours for the roads. And of course, you can show them for the day period. You can also show them for the LDEN period. Calculate again. Okay, yep. So this is just simply viewing your model. If I now double click on the road, for instance, double click on the road, then you see your properties. This road has a category 1 with a traffic flow of 300 vehicles per hour, 50 kilometers per hour. Looking at the catalogs, there's the catalog menu. Catalogs, you can go to the road vehicle catalog. And here you see the road vehicle catalog, as I've also shown you in the sheets. All the values that you need for the roads. I go into the catalog, the road surfaces. Here are the road surfaces, etc. And then, of course, the most complex one is the railway vehicles. So this is the default train type categories that we've included in iNoise with the RMR train types. And here are the tables that are shown in the CNOSSOS method itself. The vehicle transfer tables with the 4 wheel diameter options, the contact filters, depending on wheel load, traction noise, wheel roughness, the structure transfer, and the aerodynamic noise. And when you create a vehicle, then you select out of these separate also catalogs, in fact. So when you add a new train type, then you need to select what type of vehicle transfer is it, what type of contact filter, what traction noise, what wheel roughness, etc. And so you can define your own railway types. Okay, now next, delete this one first, I don't need this one. Now I want to create a new model. So let's call it demonstration. And here you can select the calculation method. So until previous versions of iNoise, CNOSSOS EU was not included, and also Analyst was not included. Both are new in iNoise 2024, but we're going to select the CNOSSOS EU method for this demonstration model. Okay, it's added to the list of models. I'm going to open this model, and we start with nothing. So the next I want to show you is how to import, in this case, buildings. And as you can see, we've got several formats that you can use for importing CAD files, geodatabase files, geomodel files, geopackage, GML, mapinfo, OpenStreetMap. That's a very convenient one. Shape files, but I'm going to text files and QSI, but I'm going to show you the import of shape files. So we're going to import a shapefile that's called buildings.shp. Well, that's convenient. Most likely they are buildings. Then you come in the dialog in iNoise. You need to select which layer you want to import. Well, the shapefile in many cases only has one layer, but the other formats, file formats, could have several layers, and the dialog is the same. So we select the building layer, and of course we want to create building items. Then you see the item fields that iNoise wants for a building, and here are the fields offered by the shapefile. If the field names are the same, then iNoise will automatically match them. If they are not the same, you can always select another field to connect to the ident field in iNoise, or to connect to the height field in iNoise. So that makes it very convenient importing data and selecting which attributes you want to match to your, which file attributes you want to match to your item attributes. Okay, let's import these items. And this is now importing the items. Should have opened this one. It's now saving the changes, so it has imported the buildings. There's some more feedback if I would open the information section, but I forgot to do that anyway. Doesn't matter. I can now open the information section. And now you see what iNoise has done. It has imported 51,000, over 51,000 buildings. And when I zoom in, you see all these buildings, nice polygon buildings with a height 11.47 meters. Well, similarly, you can do that with the roads. So you import shape files. Go to the city data folder, and I want to import roads. Again, roads, and I want to create roads. And now you see here that it's importing, it's imported 1961 roads. Okay, the last I want to import is this agglomeration boundary, because it's a convenient shape to use. Here, city data, and that's the boundary. Yep. And I want to import this boundary as a div item, as a div area item. Div items are help items, so they do not influence the calculation, but they are very convenient for all kind of editing of your model. So this is my agglomeration boundary. Next, I want to show you how you can use the thematic coloring of, in this case, buildings, to select only the buildings with a residential use. Because if I double click on a building, you see that one of the properties of the building was also the designated use. And in this case, this is a commercial building. So here with the display settings for the buildings, you can use a thematic presentation, and you can select on any attributes, on the height, on the terrain level, but in this case, we want to select on the designated use, and you can always select the wizard, but it's already there. You can say, well, I want all these designated use, they occur in your model. 1,816 buildings have a commercial use, 16,521 a non-residential, and 33,000 have a residential use. Okay, that's good. So if I then say, okay, my buildings will get colored according to this designated use property. And you also see that here in your display options. And now you can deselect the buildings that you do not want to use for the moment, for the creating of the receivers around the facade. So I deselect the commercial buildings, I deselect the non-residential buildings. In this case, I also deselect the roads, because I don't want to see the roads. I only want to see my residential buildings. Okay, I zoom out. So now I only see the residential buildings, but I want to select the residential buildings within this agglomeration boundary. So I select the agglomeration boundary, then I use my right mouse button and do a select with polygon to select only the items inside this polygon, inside this agglomeration boundary. Say okay. So now all the buildings are selected within the agglomeration boundary with the function residential use. So that's what I wanted to achieve, because now I can use the menu option, batch create items, receivers at facades. So now I can create automatically receivers around those selected buildings according to a certain CNOSSOS method. In this case, I want to use CNOSSOS case 1. And then iNoise will create receivers around those buildings according to CNOSSOS EU case 1. It is also described in the CNOSSOS method how to divide, how to create receivers around the facades. So those are, what is it, 136,000 receivers. Okay, now it's saving the changes. Yep, receivers are done. And then let me see, I did not toggle the display option for the receivers. So now I activate the display of the receivers. Become a little bit black. Yep, because of course many receivers. So now I zoom in. I zoom in. So here you see all the receivers, and now I also switch on the other types of. I wanted to show you the sheds in the garden. Where are they? You see, oh yeah, here. Yeah, okay. So you see that we've now only created receivers around buildings with the designated use equals residential, and not this one, the buildings with a non-residential use, because they are sheds, for instance, or commercial use. So that's what I wanted to show you as a small example of a functionality in iNoise, which is very convenient if you want to create receivers around facades based on the function of a building. Now I switch back to my presentation, and this is exactly what I've just shown you. Then configuration and prices. iNoise, like I said, has two main configurations, the Pro and the Company configuration. Of course, the free configuration is included in the setup. The Pro configuration is for one user. The Company configuration is for the unlimited number of users. So that's very convenient if you have several users within your company that want to use iNoise. And we've got Pro and Pro plus CNOSSOS as a configuration, and you've got Company and Company plus CNOSSOS. But if you compare the Pro and the Company, so the Pro is one user, Company not limited. The Pro is 1,000 sources, and those sources can be 1,000 polyline roads. So the number of actual nodes of the road can be unlimited, but the number of polyline roads is limited to 1,000. Similarly to the number of polygon objects, it's limited to 5,000. But of course, one object, like a building, can have many nodes. So again, the number of nodes is not limited. Then the number of height lines is not limited for a Pro. And if you compare the sources and the objects between Pro and Company, you see that the Pro has a limitation and the Company does not have a limitation. Also, your terrain model is not limited for any configuration. Then the number of supported cores are 8 for Pro and 32 for Company. That's for your calculation, of course. It speeds up your calculation. And also nowadays, multi-core computers are really affordable. It makes sense to buy a 16 core and then use hyper-threading, so you end up with a 32 core computer or even more cores. Then the methods included in Pro are ISO, Harmonize, and Analyst, and of course in Pro plus CNOSSOS, the CNOSSOS method is added. Similarly for the Company license, also ISO, Harmonize, and Analyst, and Company plus CNOSSOS, of course, adds the CNOSSOS method. Source Explorer software is included in all configurations. Source Explorer can be used for calculating the sound power level of industrial sources according to several methods. Price per year starts at €545 for a Pro and goes up to €2,645 per year for Company plus CNOSSOS. Those are the prices. And I know that many of you will know the predictor software also. So how do they compare? How does iNoise compare to predictor? I've made a table. Here are the two main configurations of iNoise, the iNoise Pro and the iNoise Company. And here are the 5 configurations of predictor. And of course, the iNoise Company is a very convenient configuration because you've got an unlimited number of users for modeling and calculation, while all the other configurations are only for one user. And also, iNoise does not need a USB husky, while predictor does need a USB husky. Then the number of cores supported, Pro 8, Company 32, predictor starts from 2, maximum of 8. Then the model size in iNoise Pro is a medium plus, because like I explained, iNoise Pro can really have 1,000 polyline roads. So it can be a really big model. And the company, of course, is a large plus because actually it's an unlimited, while all the model sizes in Predictor are limited to a certain number of nodes. Source Explorer is included in iNoise, and in Predictor it's called Acoustic Determinator. And in these 3 configurations of Predictor, Acoustic Determinator is not included, only in the top end configurations it's included. Then the ISO 9613 method is included in all configurations. Harmonize and Analyst is included in all configurations. CNOSSOS EU, of course, in the iNoise Pro plus CNOSSOS and iNoise Company plus CNOSSOS, it's included. And CNOSSOS is included in these 3 configurations in Predictor. And then I think the main difference between iNoise and Predictor is that iNoise does not support other methods like CRTN and NPB. So those are not supported by iNoise. So that's about it.